Most labs will tell you your B12 is fine if the number is above 200. Neurologists who specialize in cognitive decline won't start a patient on a protocol until it's above 500. That gap, right there between those two numbers, is where 1 in 3 adults over 60 is living right now. Tested, cleared, and slowly losing ground. Your doctor saw a normal result. What he did not see is what that number is doing to your hippocampus. I'm Dr. Gloria Reed, nutritional neuroscientist. Let's get into it.
Here is why this matters. The sublingual tissue, the thin membrane under your tongue, connects directly to a dense network of capillaries that feed into your bloodstream without passing through the digestive system first. For people over 60, the digestive pathway for B12 is frequently compromised, a condition I am going to explain in detail, which means swallowing a standard B12 supplement often delivers almost nothing to the tissues that need it most. The sublingual route bypasses that blockage entirely. The B12 enters your blood and reaches your brain within minutes, not hours. The dose is 1,000 micrograms of methylcobalamin, not cyanocobalamin. The difference between those two names is the most important thing I am going to say in this video. But hold that thought for just a moment. Do this tomorrow morning, before coffee, before food. 60 seconds under the tongue, then swallow. That one change, done consistently, sets the foundation for everything else I'm going to show you. Keep that in mind, because when I show you the full protocol later, this piece is what makes everything else work. Most people believe that B12 deficiency is something that only happens to vegetarians or to people who are severely malnourished, and that is not entirely wrong. But here is the part that changes everything, and that almost nobody explains. After the age of 60, the body loses its ability to absorb B12 through the normal digestive pathway, even in people who eat meat every day, even in people whose diets are otherwise excellent. The mechanism responsible is the gradual decline of something called intrinsic factor, a protein produced in the stomach lining that is required to escort B12 through the intestinal wall and into the bloodstream. Without adequate intrinsic factor, dietary B12 and most supplemental B12 passes through the digestive system and is excreted. It never arrives. This is why a person can eat steak 3 times a week and still be functionally deficient. But the deficiency itself is only half of the problem. What the deficiency causes is where the real damage happens. When B12 is insufficient, a specific amino acid called homocysteine accumulates in the blood and in brain tissue. Homocysteine is not a foreign invader. It is a naturally occurring byproduct of protein metabolism. In a healthy system, B12 converts homocysteine into a harmless compound called methionine. When B12 is low, that conversion stalls. Homocysteine builds up, and elevated homocysteine is directly toxic to brain tissue. Think of homocysteine as acid in the plumbing of your brain. It corrodes the vessel walls, damages the neurons, and, this is the part that has been documented in brain scans, it physically shrinks the hippocampus. The hippocampus is the structure where new memories are formed and stored. When it shrinks, the ability to recall names, form new memories, and retrieve words becomes measurably impaired. And the shrinkage is not subtle. It is visible on MRI. That is the hidden driver behind a significant portion of what gets labelled as normal cognitive aging in people over 60. Before I go further, have you ever had your B12 levels tested, received a result that said normal, and still felt like something was off with your memory or your thinking? Just comment yes or no below. I ask because what comes next is specifically about why that normal result may not be telling the whole story. Let me show you exactly what elevated homocysteine does inside your brain, because understanding this mechanism is what makes the protocol make sense. Your hippocampus is a small, curved structure deep inside the brain, roughly the size and shape of a cashew. It is the center of memory formation. Every new name you learn, every recent event you store, every word you reach for mid-sentence, That process runs through the hippocampus. When it is healthy, it is dense with active neurons communicating rapidly across tight synaptic connections. When it is damaged, those connections become slower, sparser, and less reliable. Homocysteine damages the hippocampus through two simultaneous pathways. First, it directly damages the endothelial cells lining the small blood vessels that supply oxygen and nutrients to hippocampal tissue. Those vessels become less flexible, more prone to microinflammation, and less efficient at delivering what the neurons need to function. Second, homocysteine generates reactive oxygen species, a form of cellular oxidative stress that attacks the neurons themselves, triggering a process of gradual cell death and synaptic pruning. The result, documented on brain imaging, is measurable reduction in hippocampal volume. Not metaphorical shrinkage, actual measurable shrinkage. A landmark study published in the Proceedings of the National Academy of Sciences in 2013, led by Dr. David Smith and Dr. Helga Refsum at the University of Oxford, followed 168 elderly adults with mild cognitive impairment over 2 years. Half received high-dose B vitamins, B12, B6, and folate, specifically chosen to lower homocysteine. The other half received a placebo. Brain imaging at the end of the trial showed that the B vitamin group had dramatically slower rates of brain atrophy, up to 53% less shrinkage in specific regions, including the areas most critical for memory. In the participants with the highest homocysteine levels at the start, the effect was even more pronounced. That is not a small finding. That is a dietary intervention producing half the brain atrophy rate of a control group, documented on MRI. This is where the morning action connects directly. Methylcobalamin, delivered sublingually, is the precise form of B12 that drives the conversion of homocysteine back into methionine. When that conversion happens consistently, homocysteine levels fall, and the toxic pressure on hippocampal tissue begins to ease. The daily sublingual dose is not a supplement ritual. It is a direct counter-mechanism to the damage happening in your brain right now. There is a second mechanism that B12 deficiency drives, one that affects not just memory, but the speed and clarity of all cognitive processing, and it operates through a completely different pathway. Every neuron in your brain is wrapped in a protective coating called myelin. Myelin is to neurons what insulation is to electrical wiring. It allows signals to travel rapidly and cleanly from one neuron to the next, across the vast network of connections that makes thinking, recalling, and communicating possible. Without intact myelin, signals travel slowly, get disrupted, and sometimes fail to arrive at all. Vitamin B12 is directly required for the production and maintenance of myelin. Specifically, methylcobalamin participates in the synthesis of a compound called S-adenosylmethionine, which is essential for methylation reactions throughout the nervous system, including myelin repair. When B12 is chronically low, myelin begins to thin. The degradation is gradual, years, sometimes decades, which is why it is so consistently mistaken for normal aging. The lived experience of myelin degradation is not dramatic. It presents as thinking that feels slightly slower than it used to. Words that arrive a half-second late. Conversations where you are tracking what someone is saying, but the response forms more slowly than you would like. A sense of mental effort where ease used to be. Most people describe it as not as sharp as I used to be. What they are often describing is compromised myelin function. A study published in the Journal of Neurology, Neurosurgery and Psychiatry in 2016 by Dr. A. David Smith's research group at Oxford demonstrated that elevated homocysteine combined with low B12 status was associated with accelerated white matter degradation, the myelin-rich pathways connecting different brain regions. White matter integrity directly correlates with processing speed and cognitive flexibility. As white matter degrades, both slow. The critical point here is the connection between these two mechanisms. These two pathways, hippocampal atrophy from homocysteine toxicity and myelin degradation from insufficient methylcobalamin, do not work in isolation. They feed each other. Elevated homocysteine suppresses the methylation reactions needed for myelin repair. Degraded myelin slows the signal transmission that the hippocampus depends on. And that is exactly why addressing both simultaneously produces results that addressing only one never does. The protocol I am about to give you is built to hit both pathways at the same time. Before I walk you through exactly how to do this, I want to be direct with you. What I am describing is not a replacement for medical care. If you are on medication, particularly metformin, proton pump inhibitors, or any medication that affects stomach acid, speak to your doctor before making changes, because several common medications actively deplete B12 and may require supervised correction. What this protocol is: an evidence-supported, low-risk nutritional intervention that works alongside what you are already doing, not instead of it. Most people who try to address a B12 deficiency do one thing that completely cancels the benefit. They take cyanocobalamin. Cyanocobalamin is the synthetic form of B12 found in most drugstore supplements, most standard multivitamins, and most prescriptions written by general practitioners. It is inexpensive, stable, and widely available. It is also not the form your brain uses. Before cyanocobalamin can participate in any neurological process, including homocysteine conversion and myelin synthesis, your body must first convert it into methylcobalamin. That conversion requires a series of enzymatic steps that become progressively less efficient after age 60, and that fail almost entirely in the roughly 40% of people who carry a common genetic variant called MTHFR. In those individuals, cyanocobalamin supplementation produces measurable improvement in blood B12 levels, while producing very little change in brain function, because the active form never arrives at the neurons. This is why a person can take B12 supplements for months, have a follow-up blood test showing elevated B12, and still experience worsening brain fog. The lab result looks corrected, the biology is not. Here is the correct way. The first component is methylcobalamin B12, 1,000 micrograms daily, delivered sublingually, not swallowed. The sublingual route bypasses the compromised intrinsic factor pathway entirely and delivers the active form directly into circulation. Use a liquid or dissolvable tablet, not a hard tablet you simply swallow. Place it under your tongue, hold it for 60 seconds, then swallow. Do this every morning before eating or drinking anything, including coffee. Timing matters. Absorption through the sublingual tissue is highest when the mucous membranes are not coated with food residue. The second component is methylfolate, specifically 5-MTHF, also written as L-methylfolate, at a dose of 400 to 800 micrograms daily, taken with your first meal of the day. Do not use folic acid. Folic acid is the synthetic form of folate, found in fortified foods and most supplements. Like cyanocobalamin, folic acid requires conversion to its active form before it can function. In people with MTHFR variants, that conversion is significantly impaired. Unmetabolized folic acid does not simply do nothing. It competes with active methylfolate for receptor sites, potentially worsening the deficiency it was meant to correct. Methylfolate is the active form. It requires no conversion. It is available in any health food store. Methylfolate is the second arm of the homocysteine conversion pathway. B12 handles one step of the reaction. Methylfolate handles the step that follows it. Without both, the pathway runs incompletely, and homocysteine continues to accumulate even with B12 supplementation. This is the most common reason people take B12 and notice only partial improvement. The third component is vitamin B6 in its active form, pyridoxal 5-phosphate, abbreviated P5P, at a dose of 25 to 50 milligrams daily, taken with a meal. Standard B6, pyridoxine, also requires enzymatic conversion before use, and that conversion is impaired in people with compromised liver function, which becomes more common with age. P5P is the form that is ready to use immediately. It completes the third arm of the homocysteine conversion cycle, ensuring the pathway runs fully and efficiently. Do not take this trilogy on an empty stomach, except for the sublingual B12. The methylfolate and P5P are best absorbed with food, specifically a meal containing protein, because the amino acid methionine produced by the completed homocysteine conversion cycle interacts with dietary protein metabolism. What not to combine? Do not take high-dose B12 alongside high-dose zinc without spacing them by at least 2 hours. Zinc competes for absorption pathways with some B vitamins at high doses. Do not combine with alcohol on the same day you take your sublingual dose. Alcohol directly disrupts the methylation cycle and partially reverses the homocysteine conversion you are trying to support. And again, if you take metformin for blood sugar or a proton pump inhibitor for acid reflux, discuss this protocol with your doctor. Both of those medications actively block B12 absorption and may require a higher therapeutic dose to overcome the depletion. By day 7, most people notice one subtle but specific change. Morning mental clarity arrives faster. The grogginess that used to linger for an hour after waking begins to lift within the first 30 minutes. That is not placebo. That is the methylation cycle beginning to run more efficiently, which has direct downstream effects on neurotransmitter synthesis, specifically dopamine and serotonin, that regulate alertness. By day 14, word retrieval begins to improve. The specific experience is that the pauses, those moments where a word you know perfectly well simply refuses to surface, become shorter. The word arrives. Not always perfectly, but the gap narrows. That is the hippocampal environment beginning to improve as homocysteine levels fall and microvascular pressure eases. By day 30, the cognitive fog, that pervasive sense of working through something dense and slow, begins to lift noticeably. People in their families start commenting that they seem more present, more responsive, sharper in conversation. That is not coincidence. That is the myelin repair cycle gaining enough momentum to produce observable changes in signal transmission speed. Remember the fog I described at the beginning? The deficiency that affects 1 in 3 adults over 60 that standard blood tests miss. By day 30, if the protocol is followed correctly, you are no longer simply describing that fog. You are measuring its absence. 3 supporting factors will accelerate everything I just described, and each one takes less than 10 minutes a day. First, sleep on your left side. The glymphatic system, your brain's overnight waste clearance network, clears homocysteine and other metabolic byproducts at a rate approximately 25% higher in lateral sleep position than in back sleeping. Left side, specifically, produces slightly better drainage through the lymphatic vessels near the brainstem. This costs nothing, requires no equipment, and amplifies the effect of the protocol while you sleep. Second, take a 10-minute walk after your largest meal of the day, outside if possible. Post-meal walking reduces the blood glucose spike that temporarily impairs hippocampal function, a spike that occurs even in metabolically healthy individuals. It also triggers a modest release of BDNF, the brain's growth factor, which directly supports the neuronal repair that the B12 trilogy is initiating at the cellular level. 10 minutes is enough. The timing, immediately after eating, is what makes it effective. Third, before you touch your phone in the morning, spend 5 minutes breathing with a pattern of 4 counts in and 6 counts out. A longer exhale than inhale activates the parasympathetic nervous system and reduces morning cortisol. Elevated cortisol directly suppresses B12 absorption and impairs the methylation reactions the protocol depends on. This 5-minute practice is not optional decoration. it is protecting the mechanism you are building. Here is what we covered today. Vitamin B12 deficiency, specifically the deficiency of its active form, methylcobalamin, is measurably linked to hippocampal shrinkage through homocysteine toxicity and to cognitive slowing through myelin degradation. The standard blood test frequently misses it because the reference ranges are set too low. The supplements most doctors recommend use the wrong form, and the fix is precise. Methylcobalamin sublingually, methylfolate at breakfast, P5P with a meal. Every day, consistently, for at least 30 days before you judge the result. Your brain did not develop this problem in a week. It will not fully recover in a few days. That is biology, not failure. What the research, including Dr. David Smith's Oxford trial, consistently shows is that targeted nutritional intervention over 30 to 90 days produces changes that are real, measurable, and that you will feel. Not as a dramatic transformation, as a gradual return to the clarity that used to be normal for you. If this video gave you something concrete, if it explained something you have wondered about for a long time, type the word brain in the comments right now. It tells me this kind of specific, practical information is what you need more of. And it helps this channel reach other people who are sitting with the same questions you were sitting with before you clicked play. In the next video, I'm going to show you why waking up between 2 and 4 in the morning and struggling to fall back asleep is not just a sleep problem. It is one of the earliest signs that your brain's memory consolidation system is under stress. And there is a specific biological reason it happens at that hour, one that almost nobody connects to memory. I will see you there. Your brain is not broken. It adapted. And when you give it what it needs, it adapts back. Not instantly, but reliably. I will see you in the next one.